Bismillahirrahmanirrahim. Hello and welcome to Rahman Digital Production. This is lecture number 98 of physics, and in today's lecture we are going to discuss about the uses of echoes. Uh, Echoes have various uses across different contexts. In this regard, the first one is communication. The second one is in the form of entertainment. The third one is in navigations, just like few animals like bat and certain birds uses it for navigation to avoid obstacle during flight. Medical imaging, we will discuss that in a moment in greater detail. The fifth one is sonar. We will also discuss this. The sixth one is the geology and seismology. The seventh use of this is architectural acoustics. Number 8 is safety and warning system. Number 9 is art and expression. Number 10, communication in remote areas, just like in the case of radio signals. Number 11 is educational demonstration. Number 12 is echo chambers. These are just a few example. These are just a few examples, but they highlight the diverse and important role that echoes plays in various aspects of our lives and the natural world. Let us discuss one of them in greater detail, and that is very important, and that is by sending out a signal in the form of pulse of sound and noting the time interval before the reflected signal arrives. The depth of the sea and the position of the shoals of fish can be found during a war. Echo sounding with high frequency sound waves was used to detect the position of mines. You can see that this ship is sending the ultrasonic waves. There are refraction and compressions inside this. They are touching the seabed, and they are uh, going back after touching the seabed. The backward movement is shown by the dash curved lines. So when the system is sending waves and receiving it again, the sound generator is noting these waves time, and after necessary calculation they can find the depth of the sea and as well as the shoals of fish as well. So this is a very important use of the in the war arena. They are used to detect the position of mines. So let us explain this more with the help of a work example. But before that, let me tell you that bats use a form of echo sounding to detect the presence of obstacles when they are flying. The bat emits a high frequency sound which is reflected by an object in its path. The echo is heard by the bat, which can then pinpoint the position of obstacle and so avoid them. This is another very important use of the ultrasonic waves, the echoes. So now we are turning our focus to the uh, work example, and the work example is saying a man stands some distance away from a cliff as shown in the figure. He gives a shout and hears his echo 4 seconds later. Note the time. I wrote it for you people. Here is 4 seconds later. How far away he from the cliff? Another information is given. Take the speed of sound in air to be 330 meter per second. So I also denoted that with the v is equal to, which is speed of sound. Now we know that v is speed is equal to s divided by t, but in this case we are taking two distance. One is going from this side and then coming from that side, so it will be 2s. S is not second, it is a distance. So we are going to put the value inside it, which is 330 and uh, multiplied by 4. That is multiplied by 4 and then divided by 2. So we are finding the s, so s will be v into t divided by 2. V is 330 and t is 4 seconds and 2 is coming from the formula. So after calculation we will get that it is 660 meter. That was the usage of echo, that we can find the distance as well. Next very important topic is ultrasound. We are hearing this term in medical terminology very frequently. Uh, Ultrasound is replacing the X-rays. So, what is ultrasound? First of all, we have to understand that concept. Sounds with frequencies above the upper limit of human audible frequency range is known as ultrasound. Generally, we would classify ultrasonic frequencies as above 20 kilohertz, which is beyond the listening power of human ear. Now, we understood that what is ultrasound, where we can apply these ultrasound. So there are two very important applications of ultrasound is there. The first one is in medical diagnosis. Ultrasound can be used to obtain images of internal parts of the body. Indeed, it is commonly used in prenatal examination to examine the development of the fetus. The development of the fetus in case of the uh, ultrasound. Ultrasound pulses are sent into the body by means of a transmitter. The echo reflected from any surfaces within the body or received. By noting the time interval, the depth of the reflecting surfaces within the body may be known. You can see that in the figure. In medical diagnosis, the doctors are using this ultrasound, X-rays to find the position of the fetus and the development of the fetus as well. There is an ultrasonic transceiver which is sending ultrasonic sound, and after touching the body of the fetus it is reflected back and the time is noted. So different organs develop in the fetus are then uh, seen. This is the original ultrasound people are doing in different laboratories, and that is a sketch of that. So the first diagnosis is ultrasonic waves used in prenatal examination. So in this way we can use that. The second very important usage is ultrasound in cleaning. Yes, those parts of the object to which human beings cannot reach by ordinary ways, that can be cleaned by the ultrasonic cleaner. The ultrasonic cleaner is working in the following way. The transmission of high energy ultrasound may result in the creation of cavitation bubbles. As you can see in this picture that there are cavitation bubbles inside this. These are the bubbles inside that, and remember that these bubbles are created when the sonic operating and ultrasonic transducer are sending these waves, and in these waves there are rarefaction and compressions. Remember, dear learners, that cavitation bubbles are produced at the position of rarefaction, not compression. What the cavitation bubbles are doing, we will discuss that. Cavitation bubbles are created at the sites of rarefaction. These cavitation bubbles may displace contaminant from surfaces. This effect also allows fresh chemicals to come into contact with the contaminant remaining on the surface of the surface to be removed. Ultrasonic cleaning is especially effective in the cleaning of irregular surfaces or internal cavities and passageways. Dear learner, let us discuss that there is a dirt or contaminant and there is a surface, just like we are using different brands of powders to clean our clothes. Here also solvents are used which we will send to the different parts of irregular shaped objects. Cavitation bubble is vibrating this dirt or contaminant and separating it from the body as shown in this case. So in this way the ultrasound is used in ultrasonic waves are used in the cleaning of different surfaces of the uh, object. Dear learners, very important topic of this lecture is measuring the speed of sound. The speed of sound in air can be measured by either a direct method or an indirect method, which is known as echo method. So let us discuss both these methods in detail. First one is a direct method. Let us discuss that to measure the speed of sound in air by a direct method. For that, you required a starting pistol. The second one is stopwatch and measuring tapes. These three things are required to measure the speed of sound. What actually you will do by means of a measuring tape, observe A and B, observer A and B are positioned at a known distance S apart in an open field. So A and B positions are measured by the measuring tape. So this means that we can find the distance S, which is necessary for finding the speed. Now in the second part, observer A fires a starting pistol. Third one is observer B on seeing the flash of the starting pistol start the stopwatch and then stop it when he hears the sound. The time interval T is then recorded. Ladies and gentlemen, a typical set of data for S and T is given here. That is S, and S is 800 meter. It means that this distance is 800 meter measured by the measuring tape, and the time when this pistol is showing fire. So this person is seeing, by seeing that flash of the light, this person B is starting the stopwatch, and when the waves, the sound reaches the ear of this B person, he stop the stopwatch and noting the time. So typical data is 2.4. Let me tell you, dear learners, that if we want to be very much precise, then you have to perform this experiment many times, and then you have to find the average. For example, might be at uh, first recording, this person B will record 2.8. The second might be 2.2. The third might be 2.5, 2.3, 2.4, 2.6. And as many times you are performing this experiment, you will get very accurate result, and this is the nature of experiments the scientists are performing. So dear learners, 2.4 second is the typical data taken from this experiment. Then we have to use this formula. Speed is equal to distance per unit time. The distance in this case is 800 meter and the time is 2.4 second. So after necessary calculation, we will get 333 meter per second is the value, which is very much nearer to the theoretical value. Always the practical values are a bit divergent from the original theoretical values, but it is quite acceptable. The theoretical value of velocity of sound, the speed of sound is 330 meter per second. But because due to the defect in the instrument or in the noting of time and distance by human beings, it is it will be nearer to it. So 327, 28, 29, 30, 31, and 32 up till 33 is quite acceptable values. But if it is 400 or 500, then you have to think on your experiment and you have to take the values again. So this method was the direct method, but keep in mind the result of the speed of sound in air we can be improved in two ways. Number one, as I told you, repeat the experiment a few times and compute the values of speed of sound for each experiment. Find the average value. This procedure minimizes random error in finding the time interval between seeing the flash and hearing the sound. That is what I told you. Number two, observer A and B exchange positions and repeat the experiment. This procedure will cancel the effect of wind on speed of sound in air. If there is air blowing hotly, then this will affect the experimental result of the speed of sound. So for that particular purpose, the position of A and B, they should change with each other. So if the air is from one side, the A from the A to B, then A should go to the position of B and vice versa. So the result and the error, which is called random error, might be minimizes. Now let us discuss the second method, which is indirect method, and that is through echo, and that is the main purpose of this topic. So in this case, to measure the speed of sound in air by an indirect method, and that is also known as the echo method, we need two blocks of wood for clapping. The second one is stopwatch. The third one is measuring tape. Ladies and gentlemen, concentrate on the figure at the right side of your screen, and you have to perform the following hand-on activities. The first one is measure the distance S at right angle to a large wall. These should be no other there should be no other large reflecting surfaces nearby. Otherwise, reverberation will be noted, and as a result, you will not get the correct answer. So it should be at 90 degree. You should not measure it in this way. That is not. You have to measure this with the 90 degree. Here is in this case. That is mandatory for this experiment. Okay, the second step is make a sharp clapping sound by knocking two blocks of wood together. Repeat the sound at regular interval to coincide with the echoes. In other words, the second clap coincides with the echo from the wall from the first clap. So it must coincide with, it should be in regular intervals. And then you have to clap the two wooden blocks in such a way that it coincides with the incoming echoes from the wall. If that is out of order, then your experiment will not give you the correct answer. It means that when you are clapping like this, listen, it should be like this. But if you are doing one time like this and second time like this and third time like this, then it will not coincide with each other and they will block the sound of each other. Now the third step is starting at 0 as the stopwatch is started. Count the number of claps and stop the stopwatch at say 50 claps. After the 50 claps, you have to stop the stopwatch. Again, I am telling you, repeat the third step to find the average time for 50 claps again. Hence, calculate the time interval t between the claps. A typical set of data for S and T is S is equal to 100 meter and T is equal to 0.61 second. Now, this data is enough to find the speed of sound in air. V is taken as distance traveled by sound divided by time interval between claps. So I am writing this step in this particular formula. V is equal to 2S divided by T. You must know that why we are using 2S, because the outgoing sound waves and the incoming sound waves will be taken as twice the distance. From one side it is going, it will cover the distance, and from that side when coming again to our ear, then it will cover again the same distance, so it will be 2s. Now next is 2 into 100. We put the value of this S and T, and that is 0.61 meter per second. When we calculate it, so that is equal to 322. Now, dear learners, you can see from both the experiment that the echo method, which is also known as indirect method, is very nearer to the uh, theoretical value, that is 330, while in case of direct method there was a difference of 3 meter per second, and here it is 2 meter per second. So this method is the precise one. Ladies and gentlemen, let us stop it here. Tomorrow we will discuss the pitch, loudness and quality of sound, that is also known as characteristics of sounds. So stick for that topic with this channel. Thank you very much for your time. Have a nice time. Allah Hafiz.